Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. I teach online seminars for exams PFM, IFM, and LTAM, and you can find information about them at smartyurl.it/btdt-online. I authored study manuals for exams PFM, IFM, and LTAM, and you can find information about them at smartyurl.it/btdt- and then the exam name. BTDT stands for Been There, Done That, which is, in my view, how you should be prepared for the exam. When you take an actuarial exam, every time you look at a problem, you should be able to say, been there, done that, because you have done hundreds, if not thousands, of practice problems of all possible types, and you have done problems like that, and you know immediately what to do, and you just do it. There is no time for thinking on the exam. Thinking is the last resort of the unprepared. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smartyurl.it/help ISU actuary. Here's a problem for today. This is problem number 6 from multiple choice section of the first ever exam LTAM, which was given in October 2018, not so long ago. And of course I give you also the URL for where I will put this problem as a video. You are given the following mortality rates and mortality improvement factors phi of xt, and you have a table with mortality at age x in the year 2018 for ages x equal to 60, 61, 62, and 63, and then you have these mortality improvement factors for going 1 year into the future, 2 years into the future, and 3 years into the future. So 2 years, 2019, 2020, and 2021. And we are asked to calculate the probability that a life who is age 60 in 2018 survives to age 63, so over 3 years. So the probability we're looking for is the probability that a 60-year-old in 2018 survives 1 year, which is 1 minus q of 60 2018, times 1 minus q of 61 2019, because that 60-year-old in 2018 will become 61-year-old in 2019. And times 1 minus q of 62 2020, because that 60-year-old will become a 62-year-old in 2020. And remember, this is the most important formula you need to remember about mortality improvement. Q of xy is equal to 1 minus phi of xy times q of xy minus 1, because mortality improvement relates basically compares people of the same age from two different age cohorts. So this is a person who is X in year Y and a person who is X in year Y minus 1. Same age in 2 different years, so they must have been born at different times, right? So different cohorts. Okay, using that formula and the data given in the problem, we have Q of 60 2018 is actually given as 0.24. Q of 61 2019 is equal to 1 minus phi of 61 2019. Notice that this is the same age and the same year, so that should help you remember. So phi has the same age and the same year as Q that we calculating, but it's multiplied by Q of 61 2018, so 1 year earlier. And those are given in the table, so this is 1 minus 0.038 times 0.25, and that's equal exactly to 0.2405. Q of 62 2020, well, that's 1 minus phi of 62 2020, the same 62 2020 as on the left-hand side, times Q of 62 2019, 1 year earlier. A person who's 62, the age we're looking at, but 1 year earlier, so different cohort. And then that's not directly given in the table, that Q, but we're going to refer it to Q in 2018. So we will write the second part, just the second Q62 2019, that expression, as 1 minus phi of 62 2019, again the same 62 at 2019 as in the Q that we rewriting, times Q of 62, the same age but 2018, 1 year earlier. Now everything that we have here is given in the data in the problem, in the table in the problem. So this becomes 1 minus 0.035 times 1 minus 0.036 times 0.26. We multiply it out, that's approximately 0.2418676. And then we plug it all into the initial formula that in the beginning I told you. That's what we're looking for. So this becomes 1 minus 0.24 times 1 minus 0.2405 times 1 minus 2418676. We multiply it out and it's approximately 0.4376092, which is answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.